Welcome back, all of you. I hope all of you are doing very well. It's been quite a few days that we haven't met. As you all know, I was quite busy with due to some personal reasons, but it's all right. No matter, we are back again with a completely new, different, new topic. Of course, that's vectors. So the concepts based on vectors are all provided to you. So all the concepts on vectors are being provided to you already. So of course you can kindly check those videos before you really come back to this video, of course. But still then after this also you can go and check the conceptual videos which have been already uploaded, concepts on vectors. So this is not a very big chapter for us. It's a very small topic actually. We have the first exercise to be solved. The second exercise, that's on concepts of vectors. Then we have the dot products, and then we have the vector cross product, and of course we'll have the vector scalar triple product. So we have around about 1, 2, 3, 3 exercises. 1, 2, 3, 4. Yeah, 4 exercises to be solved. So it should not take. Definitely, it's not as vast as the calculus topic. So, but this chapter becomes very important. So it's very easy. At the same time, it becomes very important also because this chapter will hold the key to the next chapter, that is three-dimensional geometry. So until unless you're very well versed with vector algebra, then three-dimensional geometry, of course, definitely you're going to find difficulties. All right, so fine then, grab your pen, paper, books, and let's get ready. And before you really begin again, I would like to thank you for being so patient with me. As you all know, I was off for some due to some personal reasons. But as I said, of course, I'm back now. We are back actually again to the continuous process of learning. So please do continue to give me your support because your support really means a lot to me. Like subscribing, liking the video, because these are just motivations for us, which really, when we work so hard every day to prepare the materials for you and all, and then like you also we see that you are watching and then you are learning, then like we feel motivated. All the hard work that we put in, all the effort that we put in, we feel that it's like we are encouraged. Actually, we are encouraged, and then we definitely try to give you more of what we are capable of. So all this really matters to us for your constant motivation and encouragement. So yes, please do not forget to like the video, and uh, don't forget to subscribe also, and do share also, because you will share it to one person, that other person will again share it to another person, and like that definitely there will be so many who might be still struggling to find a way to learn. Of course there are many channels to learn. I'm not saying that this is the best and all, no, but there definitely will be some who may have no idea about, not I mean they may not have an idea of even one of the sources of learning. So your one share might just go and reach out to them, so it might just help them also. So please do like, subscribe, and share. And all right, then get your book, pen, paper, pen, book, paper, book, pen, paper, whatever it is, sit on the table, take out your glass of water, keep it with you. It's not going to be a very big exercise, but let's begin then. All right, so shall we begin with our classes? Okay, I've given you a fun fact here before we really jump into vectors and all. So, all right, so many are present today. All right, then it's good to see that many of you are turning out each passing day. I can see some new names also turning out, so welcome. And it's good to see each and every one of you turning out. It's always, as I say, it's always an encouragement for us. So it's good to see each and every one of you communicating also. All right then, so let's begin with vectors. As I said, I hope you have gone through the previous videos, concept videos. Please do go through this. And after this, the next topic will be on vector dot product. So that video also I'll be putting out the link in the description box below. We can check out that video. That's all concepts before we really go to the next exercise. That will be most probably tomorrow. All right, so we're going to do now continuous classes at least for a week or two, so that the course, we pick up momentum with respect to the course, because this is already a month of July, so time is running out, my dear children. Please, I hope you all are keeping a track of the time also. All right, fine then. This is a fun fact for those who join immediately once I go live, so they might feel bored. So this is just a fun fact given for those students who are very precise in their timing. So all right, all of you, a very good evening to each and every one of you. All right, so before it gets late, let's begin. Done. Modern form vectors actually appeared late in the 19th century. Josiah Wheeler, Gibbs, and Olivier Heaviside of the US and Britain independently developed vector analysis to express the new laws of electromagnetism, discovered by Scottish physicist James Clerk Maxwell. Maxwell, of course, I think you are familiar with the term, the name Maxwell in physics, class 2 of physics. Electromagnetism starts with magnetism and all those units and all. That's it. Good evening. All right, so let's begin with the exercise. I hope all of you have your textbooks with you, so I'm not going to be writing down the questions. Okay, so let's start. So exercise 10.2. 10.1, I have already done that in the previous videos and all the concept videos and all, so you can just go and check out those videos. So, chalo. Exercise 10.1, first question. 10.2, sorry. The first question is compute the magnitude of the following vectors. And these are simple questions. Let's do this quickly. Compute the magnitude of the following vectors. Magnitude of the following vectors. I believe all of you have the textbook, so today I'm not going to be wasting much time on writing down the questions. Okay? Compute the magnitude of the following vectors. So simple question. Let's find out the magnitude. That will be root over of the sum of the squares of the coefficients. That is, this is 1, 1, 1. So it's going to be 1 square plus 1 square plus 1 square. Fine. That's when you root over of 3. Second vector, let's do it quickly. Second vector is 2i minus 7j minus 3k. So its magnitude, the magnitude of vector b, would be root over of sum of the squares. So don't be bothered with the negative values. Okay, sum of the squares only. So that will be 2 square plus, you can just ignore the negative values, no problem, 3 square. Or if you wish, of course, you can write minus 3 square coefficient. So chalo, fine, no problem. So that would be 2 square 4 plus 49 plus 9. So that would be 49, 58, 59, 60, 162. Root over of 62. And the next one, number C, I think number A is done. Vector A finished. So let's go for C. I guess you can also do, but anyway, chalo. I'm just going to go for the magnitude directly. That would be root over of 1 by root 3 whole square plus 1 by root 3 whole square. Done, this one. Plus root 1 by root over of 3 whole square minus 1 by 3. Of course, it won't make a difference, but still that. So that will be 1 by 3 plus 1 by 3 plus 1. Plus 1 by 3. That's 3 by 3, so its magnitude, of course, would be 1. So yeah, good evening. All right, done. All right, let's move on to the next question. Some basic questions. Let's do it quickly. Okay. So number 2. 2. Right. Two different vectors magnitude. Two different vectors having same magnitude. There are many possibilities, like vector A. There are many possibilities. So vector A 4i plus 5j plus 3k. This is one vector. The condition is they should have the same magnitude only. So the other can be like, you can just keep the coefficients, the numerical values same. Negative minus 4i plus 5j minus 3k. You will see that the magnitude will be same, because magnitude of A would be what? Magnitude of vector A would be like 4 square plus 5 square plus 3 square. And magnitude of vector B also would be minus 4 square. You know that square for negative values, it won't make a difference. Plus minus 3 square. So if you calculate, these two magnitudes will be same. So keep the terms, the coefficient, the numerical coefficients values same. Sign you can just change, minus plus, no? So here, of course, normally there are infinite number of possible arrangements that can be done. Okay, infinite. So these are not the only two answers. You can have your own. All right. So there's some like conceptual questions only. Okay. All right. Done. You can write your own also. Just having same magnitude, different directions, different vectors having same magnitude. What is the third one? Question number 3. Write two different vectors having same direction. So collinear vectors, not collinear, like vectors, same direction. So that, of course, you can just write A as I plus 2j plus 3k. This is one vector. You can just start off with any vector. Then vector B, of course, you can just write maybe multiplied by 2. 2 plus 4 plus 6k, because this will be 2 times of I plus 2j plus 3k. So this is nothing but 2 times of vector A. So you can see that 2 times of vector A. So vector B is 2 times of vector A. So definitely they are in the same direction, having different magnitude. Maybe magnitude can be different. Here the question is same direction. Now, so their magnitude can be different, but this proves that vector B is simply what? 2 times. That is like double of. This is vector B and this is vector A. So vector B is double of vector A. Positive sign means in the same direction. So if they just tell you like in opposite direction, then you can just like take negative values, negative, so minus. That way also it can be done. So there are many options here also, not only this. Okay. All right. Number 3. So answer, of course, you can write in general. Okay, like there are infinite. You can just write one example. After that, you can just write an infinite number of possibilities. Infinite number of combinations. Good evening, my dear students. All right, next is find the values of x and y so that the vectors this and this are equal. So in the conceptual videos previously uploaded, it's all given. They are equal vectors, like vectors, unlike vectors, collinear vectors. Kindly, if you haven't, kindly go through it also. That will help you learn better. Okay. So question number 4, the question is very simple. That is, find the values of x and y so that the vectors 2i, this and this are equal. So we can just write like for vector 2i and 3j and xi plus yj to be equal. What should happen? To be equal, that is 2i plus 3j to be equal to xi plus yj. What happened? Their coefficients also should be equal, isn't it? If we, the concept of equal vectors. You can just write like x should be equal to 2 or y should be equal to 3, plus equal vectors, so the coefficients also should be equal. Equal vectors, so the coefficients, every term will be equal vectors, no, not like vectors, equal vectors. Everything should be equal. Okay? Okay? Chibatullah, good evening. Yeah, good to see many of you joining. Alright, find that. Okay, now let's go to find. go to question number 5. So what is the question there? 5. Find the scalar and vector components of the vector with initial and terminal points given. Question number 5. So you can just write down like solution. Okay, vector with initial point. Let's name it A. What the initial point? 2, 1. And terminal. And terminal point. And terminal point B minus 5, 7 is. Of course, there are. You can write it like this also. So the points A and B, the initial point this and terminal point this is given. So we can just write position vector of A. That will be OA vector. Position vector of A. And position, you can use this also. Position vector of B. That is OB vector. So what are the coordinates of A given to us? The coordinates of A given, you can use it directly also. Anyway. Because this concept will be required for us, so we'll just do it in this way. As I say, mathematics, there's so many ways in which you can do. So none of them would be wrong if it is done mathematically correctly. Nah? So OA would be 2i plus 1j. OB would be minus 5i plus 7j. So the question is, find the scalar and the vector components of the vector with initial point A and final point B. So that means we have to get the vector AB. So vector AB will be OB minus OA. This also I've discussed in the previous lectures and all. Alright, so OB always. So whenever you go for AB vector, it should be always position vector of B, second one, minus position vector of A. Always remember that. And whenever coordinates are given, try to get the position vector of the given points. That will definitely help you ease your problem. Okay. So OB minus OA, so minus 5i plus 7j minus 2i minus j. So that would be minus 5 minus 2 minus 7i, 7 minus 1 plus 6j. So this is the vector AB. This is our vector AB. So now the question is, ho gaya? Okay. So the question is, kya hai? Question is, find the scalar and the vector components. So it's quite simple. Scalar components. Scalar components are and vector components are. What are the scalar components? The scalar quantities only. What are the scalar quantities that we have here? Scalar quantities are minus 7 and 6, and the vector components minus 7i and 6j. So these are the scalar and the vector components. Alright. Good evening. Alright, then let's move on to question number 6. Simple question there. Okay, this one, rubbing off. Chalo. Question number 6. This is not a very big exercise. The problems are also not very huge and all. So small questions. The question is, find the sum of the vectors A, that is the vector that is given to us as I minus 2j plus k. The vector B, just addition only. As I say, this is a simple, but until unless we practice, we will never learn, isn't it? Vector C as I minus 6j minus 7k. So let's add the vectors, vector A plus vector B plus vector C. So you just have to add the vectors, vector A plus B plus C. So I plus 2j plus k. Adding, so no sign changes, so directly I'm going to write minus 4j plus 5k. Let's do it quickly. Plus I minus 6j minus 7k. So let's add them up. I. So I plus I 2 minus 2 finish. J 2 plus 2j plus 2j minus 6j, so it's minus 4 vector j. and k. 5, 6 minus 7 minus k. Simple addition rule. Minus 4j minus k vector. Alright. Fine then, let's move on to question number 7. As I say, this chapter is not difficult at all. It's very, but don't ignore it because it's going to be very important for the next chapter, vectors, three-dimensional geometry. Question number 7. A vector is given to us, vector A, that is I plus j plus 2k. The question is, find a unit vector in the direction of the vector A. We know how to find out the unit vector. Unit vector is given by the vector divided by its magnitude. So let's do that. We can do it directly also, no problem. That is I plus j plus 2k divided by its magnitude. Magnitude means we have already done it in 1 square plus 1 square plus 2 square. So that would be I plus j plus 2k divided by 2 square 4, 4, 5, 6. So that will be root over of square root of 6. So of course you can write it in an arranged manner, that is 1 by root over of 6i plus 1 by root over of 6j plus 2 by root over of 6k. So this is the unit vector. So if you try to calculate its magnitude, as we all know, the magnitude of unit vector would be 1. Got it? Okay, alright, let's move on to 8. Question number 8. Find the unit vector in the direction of vector PQ where P and Q are the points given respectively. So you have to find out the vector PQ, unit vector in the direction of vector PQ. So we have to first find out the vector PQ. Now the points of P and Q are actually given to us, so we'll have to first find out their direct position vectors. So because as I said, PQ would be OQ vector minus OP vector if you get their position vector. So let's find out position vector of the point P, that is OP vector. The points are already given. Position vector of Q, that is OQ vector. So what are the coordinates of the point P? 1, 2, 3. So I plus 2j plus 3k, and for Q is 4, 5, 6. 1, 2, 3, 4, 5, 6. 4i plus, 5j plus 6k. So PQ would be, since it is already written here, I'm doing it directly. OQ 4, 5, 6 minus I minus 2j minus 3k. So vector PQ would be 4 minus 1, 3, 5 minus 2, 3, 6 minus 3, positive 3. So this is our vector PQ. So we have to find out simple, again just like the usual question like last question, a unit vector in the direction of vector PQ. So that would be again unit vector, that is PQ cap. So that would be PQ vector divided by its magnitude. So what is PQ vector? 3i plus 3j plus 3k divided by root over of its magnitude, sum of the squares, 3 square plus 3 square plus 3 square. So that would be 3i plus 3j plus 3k divided by 9 plus 9 plus 9. That would be, I'll write directly 3 by 9, 18, 27, root over of 27, 27, so 3, 9, so that would be 3 root over of 3. I'm doing it directly, okay, plus 3 3 root over of 3 j plus 3 by 3 root over of 3 k cap. So that will be 1 by root 3I, 1 by root 3j, 1 by root 3k. So this is the unit vector in the direction of vector PQ. Oh yeah? Simple questions, as I've said. Alright, question number 9. Almost the same question again. Question number 9. For the given vectors A and B, find the unit vector in the direction of the vector A plus B. So we have to first find out vector A plus B. Let us denote this by vector C. That will be easier for us to handle. So A plus B. So let's add the two vectors, that is 2I minus j plus 2k plus vector B minus I. So I'm just going to remove this minus I plus j minus k. So 2 minus 1 I, j cancels plus k cap. So this is the vector A plus B, which we have denoted by vector C. So the unit vector in the direction of the vector A plus B, which is denoted by vector C, simple again, this one. So I plus k divided by root over of 1 square plus 1 square, because it's coefficient. So 1 by root 2I plus 1 by root 2 k cap. Okay. Alright then, let's move on to question number 10. Done? Okay. Question number 10. So what is the question there? Question number 10. Find a vector in the direction of the given vector. So let's name the vector, whatever be it, 5I cap minus j plus 2k. Find a vector in the same direction of this given vector. Of course, its magnitude is 8 units, which has a magnitude of 8 units. So this is one vector, which is, let's say, in moving in this direction. We're supposed to find another vector whose magnitude in the same direction, whose magnitude is 8 units, with the help of this. So how do we find out that new vector? It's very simple, because what we will do is we will try to find out the unit vector of this given vector. Direction to it will not change, isn't it? Direction will remain the same. So we'll try to find out the unit vector. So in that case, its magnitude will be 1. Now, if we just multiply this by 8, that is 1, 2, 3, 4, 5, 6, 7, 8. Then what will happen? We will get the vector in the same direction, which has a magnitude of 8 units. So that's what we are going to be doing. Let's try to find out the unit vector for this. That is A cap. That would be vector A divided by magnitude of the vector A. So 5I minus j plus 2k divided by root over of, shall I do it directly? 5 square 25 minus 1 square 1, 2 square 4. So that's 5 by root over 25, 30. Now 30, can we factorize? 30 to 15, 3, 5. Okay, we not factorize. Root over of 30i minus 1 by root over of 30j plus 2 by root 30k. So this is the unit vector which has a particular direction. Now what I want is a unit vector. Wallu, Mugiru, Avilan, good evening. Now this time I want a vector in the same direction with magnitude 8. So I'll just multiply by 8, that is the required vector will be 8 times of A. So if I just multiply it by 8, 8 5s are 40 by root over of 30i minus 8 1s are 8 by root over of 30j plus 18 are 16 by root over of 30. Okay, so another simple question again. Done? हो गया. Let's get ready with the other question, 11. Question number 11. What is the question? Question number 11, that is, show that the vectors, so since the vectors are not named, so let's give it a name. 2i minus 3j plus 4k, and the vector b would be minus 4i plus 6j plus 8k. So the question was, show that the vectors are collinear. I have another question. Did you miss for the past 2 weeks? Because we couldn't meet each other, isn't it, for the past 2 weeks? So we are already at the half-hour cross mark, so time to relax. So you can all have a glass of water. Are you all there? All right, let's continue. You can write on a small note. It seems like today you don't want to mention anything. You're all like keeping quiet. All right, you can write on a note, that is to prove that the vectors, any two vectors, but I'll just write here vector A and vector B. To prove that the two vectors, vector A and vector B, are collinear. We have to prove that collinear means what? Parallel. It's not parallel, but directions can be different. Okay, we have to prove that vector A would be lambda times of vector B, where lambda of course is a scalar. It can be of course vice versa also. Vector B can also be lambda times of vector A, no problem. Anyone. Then of course we can say that we can go ahead and prove that the two vectors are collinear. Now if you look carefully here, what we can have here is, if I take minus 2 common, then I'll have 2i minus 3j minus 4k. Is these two vectors same? This should be minus 8k. Okay, you can just make a correction in your text in that book if it is not correct. You take minus common, minus 2 plus plus 2 minus 3 plus 4. Make that correction. Because here we are not supposed to check, we are supposed to prove. So if it is not a scalar multiple of the other vector, if one vector is not a scalar multiple of the other vector, then it's not possible to prove that they are collinear. So definitely there is something wrong with the question here. Okay, so as I'm checking with the old textbook, it's like minus 8k. In the old textbook, we have minus 4i plus 6j minus 8k. So you can just make that necessary correction. If any more changes, then definitely I'll do it later on. Okay. So you can see that this note is done, isn't it? So I'm going to rub this part. So that means I can write this vector b as minus 2 times of vector a, no? 2i minus 3j plus 4k. First, where lambda is minus 2. That means it's in the opposite direction. Minus represents opposite direction. So we have two collinear vectors which are parallel to each other, but like suppose if this is vector a, then b is double of vector a, but in the opposite, double of vector a, but in the opposite direction. Okay? Alright. So you can just prove, therefore, you can write down, therefore the two vectors are collinear. Please write down that, therefore the two vectors are collinear. Therefore the two vectors are collinear. Can I get a half century today in the number of likes? Almost there, 45. Wow, great, 45 likes. So is it possible to get a half century? Okay, 46. Come on, you can do it. So next question, of course, number 12. Almost there. Find the direction cosines of the given vector. You can write another note there. This is another short way to find out. Okay, direct way to find out. We can write down direction cosines. There are other ways to find out also, but this would be the easiest way. Okay, so direction cosines are the coefficients of I cap, j cap, k cap of the unit vector. So this will help you directly find out the direction cosines. Okay. All right, it's 48 likes, almost there. Come on. Okay. So question number 12, that is find the direction cosines of the given vector. So the given vector is I plus 2j plus 3k. So let's find out its unit vector, that is as usual I plus 2j plus 3k upon root over of 1 square, 2 square is 4, 3 square is 9. So that would be 1 by 9, 10, 11, 12, 13, 14, root over of 14i plus 2 by root over of 14j plus 3 by root over of 14k. So this is the unit vector. Alright, so we have a half century of likes, so let's all give a clap. Come on, everybody, congratulations. Thank you so much again. Please continue your support like this. I will be furthermore encouraged to give you more again. It's very motivating, as I've always said. No? It's very motivating. Like no matter how hard we work, we don't get tired. I would rather say that. No. There are times when we also feel lazy, but when the students like eager, sir, we are ready to learn, then definitely this this tiredness also goes away. We just encourage you to come up and then teach you again. Okay. All right. So as the note goes, direction cosines are the coefficients of I, j, and k of the unit vector. I found that the unit vector of the vector that was given to us, a cap equal to this. So direction cosines will be directly done. So I can just write down therefore direction cosines are, so okay, let me just write down here. Direction cosines are coefficients of I, coefficient of j, and coefficient of Remember, direction cosines are not coordinates, okay? They are not points, they are ratios. All right, everybody's celebrating. Done? Okay, all right, let's move to next question, that is number 13. So we are going to be using this again in 13 also. All right, so I hope you have written it down. Question number 13, that is find the direction cosines of the vector joining the points A and B directed from A to B. So the coordinates only are given, you know what to do. Position vector of A, OA vector, and position vector of B, OB vector. Let's find out the position coordinates are already given, 1, 2, minus 3. So I plus 2j minus 3k minus I minus 2j plus k. Direction is from A to B, so our vector would be vector AB because the direction is from A to B. And remember, in vectors, always be careful about the direction. Okay, A to B, B to A, that will make a lot of difference. All right, so come on. So that will be OB vector minus OA vector. So that would be minus I minus 2j plus k minus I minus 2j plus 3k. So that will be minus 2i minus 4j plus 4k. So this is our vector AB. So let's find out its unit vector, that is vector AB cap. So that would be vector AB divided by its magnitude. So minus 2i minus 4j plus 4k. Let's do it directly now. This will be root over of 2 square, that is 4, 4 square 16, 4 square 16, 32, 36, that will be root over of 36. So that would be minus 2 by 6i minus 4 by 6j plus 4 by 6k. So if we simplify that further, AB cap would be minus 1 by 3i minus 2 by 3j plus 2 by 3k. Minus 1 by 3 minus 2 by 3, 2 by 3 are the direction cosines. So direction cosines of the vector AB are minus 1 by 3, minus 2 by 3 and 2 by 3. Done? Alright, okay. Alright then, so that was number almost there. 14. Let's go to now 14. I think that was 13, isn't it? Find the direction cosines of the vectors. Yeah. Let's go to 14 now. Show that the vectors, the vector, A vector, that is I plus J plus K. Show that the vector I plus J plus K is equally inclined to the axis OX, OY and OZ axis. So you're supposed to prove that it is equally inclined to the respective axis. But anyway, this will be like, anyway, let's just write down like if vector A equally inclined means this particular vector is making equal angles with respect to the x-axis, with respect to the y-axis, with respect to the z-axis. So if with respect to the, just an example, with respect to the x-axis, if this vector, let's say, is making, let's say, 45 degree, something like this, then with respect to y-axis also, it should be making, 45 degree. With respect to z-axis also, it should be making 45 degree. And that concept will be provided to us by the concept of direction cosines, because direction cosines are what? Cosine of the angle which the vector makes with the positive direction of the x-axis, the y-axis and the z-axis. All these concepts are so important. That's why I have been telling you, go back. If you haven't, please after this video, go back and check out those videos I've already uploaded for you. Concepts will be very important. So vector, it's like without concepts, it's like trying to read a Hindi book without actually knowing how to read Hindi. You know, that never happens, isn't it? So if vector A makes, let's say, angles alpha, beta and gamma with the positive direction of OX, OY and OZ axis respectively. Fine. Now let's try to find out the direction cosines. From there we'll get to know the angle, because direction cosine will give us cos alpha. With the help of that we will have alpha. So how do you find the direction cosines? Again, as usual, the vector divided by its magnitude. So I plus j plus k. So definitely this is going to be root over of 3, isn't it? Because 1 square plus 1 square plus 1, 1 plus 1 plus 1 is 3. So that's 1 by root over of 3i plus 1 by root over of 3j plus 1 by root over of 3k. So from here what we get is the direction cosines. C-O-S-I-N-E-S. Direction cosines are 1 by root 3, 1 by root over of 3 and 1 by square root of 3. Different styles of mentioning root 3. Done? So cos alpha is 1 by root over of 3. That means alpha from inverse trigonometric functions. Cos alpha, alpha would be cos inverse 1 by root over of 3. Same way, cos beta also 1 by root over of 3. Cos gamma also 1 by root over of 3. That means even beta is also cos inverse 1 by root 3. Gamma is also cos inverse 1 by root 3. So you can see that the angles which the vector is making with respect to the x, y and z axis positive direction respectively are all same. Cos inverse root 3, cos inverse root 3, cos inverse 1 by root 3. So then you can give the conclusion. So now you can give the conclusion. Chalo. You can give the conclusion on your own, as the textbook says. So the vector A is equally inclined to the axis OX, OY and OZ. Okay? Chalo, 15. One more question again. Question number 15. Done? Now this is about internal and external division. So again, this is also described to you before, but I'll just remind you of the formula, that is number 15. Find the position vector of a point R which divides the line joining 2 points P and Q, whose position vectors are already given respectively. Position vector of P and position vector of Q already given in the ratio 2:1 internally, and the other one is externally. So if you just remember, just a random internal division was, what was the formula for section formula for internal division? That was mb vector plus n into vector a divided by m plus n. And external division was m into vector b minus n into vector a divided by m minus n. These were the formulas. So of course we are going to refine it and then write down. But let's find out first the vector PQ. Okay, we will not need VQ. So because we're supposed to find out the position vector of vector R only. So you can just write down. So directly for number one, first one. That is, find the position vector of R, isn't it? Find the position vector of R. So, like, okay, well, position vector of P is given and position vector of Q is given. PQ. Position vector of P is given as I plus 2j minus k, and position vector of Q is given minus I plus j plus k respectively. So number one, that is for internal division. The ratio is also given as m is to n. The ratio is given as 2:1. Now question is, find the position vector of the point R which divides the line joining the 2 points P and Q. So directly you can write down position vector of the point R for internal division. Already given, we are going to use this concept. It will be m into position vector of this one, vector B. So here B actually represents the second point, that would be Q, isn't it? PQ. So position vector of Q plus n into position vector of P divided by m plus n. So this one, that's going to be m into, okay, what is the value of m? 2, because the ratio is 2:1, isn't it? And position vector of Q is minus I plus j plus k plus n is 1, and position vector of P is I plus 2j minus k divided by m plus n. 2 plus 1, how much? 33, isn't it? 2 plus 1 is 3. So let's calculate that. So I'm going to rub this part. This one also done, no? And this one also. So that would be minus 2i plus 2j plus 2k minus, sorry, plus I plus 2j minus k upon 3. So 2 minus I, 2 plus 2, 4j plus k divided by 3. Minus 1 by 3, 4 by 3, plus 1 by 3. Of course, if you want to write, you can write minus 1 by 3i plus 4 by 3j plus 1 by 3k. So this is the position vector of the vector R. Position vector of the vector R, which divides the line joining the 2 points P and Q internally. Okay? Alright, let's talk of externally. So as you know, that lazy person is going to make use of what I've written, EXTER and LY. So I'm going to make use of what I've written on the board. So external division would be almost same, just a minus. So 2 minus 1 will be 1. So there will be some changes then. This will also be 1. So minus, so this will become minus, this will be minus, this will be plus, so there will be some changes. This will be minus 3i, j cancels, k, 3, k, plus. Almost done. Just 2 more questions left for us. Minus 3i plus 3k. Alright. Okay. Let's go to the next question. Second last question. Second last question. Find the position vector of the point of the vector joining the points P and Q. So since position vector of P and Q is not given, let's find out the position vector of P and Q first, because only the coordinates are given here. So position vector of the point P would be 2i plus 3j plus 4k, and q would be 4i plus j minus 2k. So now directly position vector of midpoint. Now midpoint we already know. What is it? That's simple. A vector plus b vector divided by 2. And also we have already used that concept. So position vector of the midpoint will be simply 1 by 2. Position vector of p plus position vector of q. So that will be 1 by 2. 2i plus 3j plus 4k. This is k. Plus 4i plus j minus 2k. So that will be 1 by 2. 2 plus 4, 6. 3 plus 1, 4. 4 minus 2, 2. So that will be 3i plus 2j plus k vector. 3, 2, 1, 0. Boom. Okay. All right, the last question of the day then, number 17. Question number 17. Show that the points A, B, and C with position vectors. So position vector of A, that's given by vector A. Position vector of B given by vector B. Position vector of C given by vector C. You can always note down what is given to us first. After that we will take care of what we need from the question. Different ways of solving. Okay. I minus 3j minus 5k. Now the question is, show that the given points A, B and C whose position vectors are already given to us, they form the vertices of a right angled triangle. They should form the vertices of a right angled triangle. So Pythagoras theorem concept will be required here. So these are just the position vectors. So we do not know how the triangle looks like, but if we just draw randomly like this, just randomly A, B, C. So we will need a side AB, BC and CA. Remember in vectors, fix your direction in just one direction only. Of course, we prefer always anti-clockwise. So in that case, we'll have to find out AB vector, we'll have to find out BC vector, and we'll have to find out CA vector. Alright, because once after we find out these vectors, if you want the magnitude, that is if you want, that means this magnitude of this vector will give us the side AB. Magnitude of this vector will give us the side BC, and magnitude of this vector will give us the side CA. So let's find out that, because once we have the sides, we'll have to just now juggle ourselves and prove the Pythagoras theorem. So let's find out AB. So AB will be position vector of B minus position vector of A. So I'm going to do it directly to, okay. So that's 2i minus j plus k minus 3i plus 4j plus 4k. Calculate quickly. So 2, that's minus I, j plus 3j plus 5k. So that's the AB. One by one we'll do BC. Vector C minus vector B. Always second minus first. I minus 3j minus 5k minus B minus 2i plus j minus k. Do not make any stupid mistakes again, okay, with these plus minus signs. Class 12, maintain some standard at least. So I minus 2 minus I 3, this is minus 2j minus 6k. Then it was CA as per the rotation. So A minus B. So A. 3I minus 4j minus 4k minus A minus vector C. I minus plus 3j minus plus 5k. So this will be 3 minus 1, 2i minus 4 plus 3 minus j minus 4 plus 5 plus k. Now we can find out their magnitudes, that is, which will give us the sides. Calculate the magnitudes now quickly. Minus I plus 3j plus 5k minus I minus 2 minus 6, 2 minus I minus k. So let's find out the magnitude of the sides, that is magnitude of vector AB. That will give us the side AB, that would be root over of minus 1 square 1 plus 3 square 9 plus 5 square 25. So that would be root over of 35. BC vector, that is magnitude BC, would be minus 1 square 1, I'm writing it directly, minus 2 square 4, 6 square minus 6 square 36. So that would be 36, 40, 41. Then finally vector CA. Almost done. So vector CA, that would be CA, that would be 2 square 4 minus 1 square 1, 1, 4, 5, 6. No problem. Okay. Now you check. AB square C. Okay, what will be AB square? AB square is going to be 35. BC square, of course, will be 41. CA square will be 6. Now you can clearly see that AB square plus CA square is equal to 35 plus 6, that is 41, which is equal to what? BC square, or in other words, magnitude of vector AB, square of the magnitude of vector AB plus square of the magnitude of vector CA is equal to square of the magnitude of vector BC. So that's it. That verifies the Pythagoras theorem. So of course conclusion to chalo you write therefore. Finished, huh? Okay. Okay, we are already the 1 hour. We've already crossed the 1 hour mark. Anyway, that's good. All of you are keeping up with the momentum with the class. It's good to see that. So yeah, conclusion you can write down. Therefore, triangle ABC is a right angled triangle. Where will the right triangle be as per the figure here? Therefore, ABC is a right triangle. ABC is a right angled triangle. So as per this, longest side is BC. So definitely the right angle is at A. So therefore, triangle ABC is a right angled triangle. Right angled at A, 90 degree. Alright. Okay. So fine then. That should be enough for the classes. Question number 18 and 19, these are multiple choice questions, so you can just kindly try. If it is not possible, then yeah, definitely you can let me know in the comment section below. Definitely I'll do it in another video. Okay, so that's almost 1 hour past. Alright then, so thank you so much for being in the class with me. I hope to see you tomorrow again. So for tomorrow, please, I will be, you can check in the playlist of vectors. Vector dot product concept has already been uploaded. So kindly go through that video so that tomorrow when you come, the concept of vector dot product would be very, very helpful for us. Alright, and remember, vectors is really going to be important even in physics also. So this concept is very important. Dot product, cross product. Cross product will be very important for physics when you do electromagnetism, magnetic fields, electric fields, the directions and all All these are always going to be very important. Okay, all right then. Yeah, thank you each and every one of you. Good night and stay safe.